All right, I think we're good to go. All right, well, good afternoon, everyone. So this is the third general audience session. Let's just go ahead and jump straight into the presentations. I think first up is Herb. So the floor is all yours, Herb. And I can't hear you. Are you on mute?
Yeah, I was. Sorry. Yeah, so we're going to tag team this. Variety of people are going to be giving this, but we'll all work from the same set of slides. So hang on while I share those slides. Can you see the slides? Anybody?
Yes, I can see the slides.
Yep.
Okay, cool. My name is Herbert Schilling with the NASA Glenn GVIS Lab, Graphics and Visualization Lab, and we're going to first go do a quick overview of the lab and some of the things that we've done, and then we'll go into some detail on some of the projects by our senior developer and some interns. So here are the presenters. It'll be me and Rich Reinhardt doing the overview. Paul will talk about some of his work, and then interns Jacob and Caleb will also follow with some of their work. Just a quick overview slide, including a link to our website and our social media, so please follow us at NASA_GVIS. Give just a brief overview of the history, talk about the team, and some of the hardware and software that we have, and some of the applications and what some of the things are on the horizon for us. The GVIS Lab is actually part of a larger team, the Scientific Computing and Visualization team at NASA Glenn. Here's a picture of everybody who's involved in that currently. We're part of the Chief Information Office, and we've been around for over 30 years, 25 plus years VR experience, and 5+ years of AR experience. We have a variety of different hardware, a lot of things that a lot of you already talked about. One of the big differences is we do have a 4-wall cave. We're kind of sitting in front of it right now, and Rich will talk about that more later, plus some of the usual headsets. A few other items for displays that we have that we use mostly for outreach, like the Z-Space and the Looking Glass. We won't really talk much about any of those, but we have them and we make use of them a lot for outreach. Primarily a Unity shop, and we also do some things with high-end 3-dimensional time-varying visualization of data using things like PairView. We also use Improve for doing some collaborative VR work. And I'll let Rich take over from here.
Well, thanks, Herb. As Herb said, behind me is the cave, assuming you can see that. We have a 4-wall cave, 4K laser projectors, and it's been fun to come back from COVID to see what works or not. And we're currently, during COVID, we had a state-of-the-art surround sound system installed, and it has it's like an 11.1 system right now that's directly above the area that people would stand in. So but we haven't even gotten to that. We have 2 computers that drive our cave. We're a Linux shop and a Windows shop, and we're currently stepping through that to see where we left off 2 years ago. And that's it.
Right, thanks. Oh, here's a diagram to give you kind of a visual of what that looks like. Just some still photos of people actually in the cave. Then for some headset-based applications, I don't know if we have, yeah, we do have video. I always forgot. So this is something that Paul created a while ago. Visualization for the wind tunnel. Again, it's mostly for outreach, but it does show some data to give you the user some idea of what's going on. So it's just as much about the experiment as the facility. And I'm going to blow through these things so we have enough time for the others. Here's another thing that Paul created as an outreach visualization for the X-59 Quest. And
all of these were developed for head-mounted display, Oculus-type devices.
Yeah, we do a lot of work with Aeronautics Mission Directorate, both at the center and the agency. And the outreach is for showing off the projects, facilities, technologies, and things like that. So here's an example of a facility, another one that Paul created, test facility for some engine blade design. It's very interactive. Cool things in it. You can watch video in VR, which is fun. And then at the end, you can shrink yourself so that you can go inside the engine. Paul did a great job of having explanations of what's going on in the facility. This is something, and this I'll let Paul take from here. He's going to just talk about this. Go, Paul.
Thanks, Herb. Hello, everyone. My name is Paul Catalano. I'm the senior VR developer in the GVIS lab. I've been developing VR and scientific visualizations now for about 20 years. And a little background here. Recently, the Aerosciences Evaluation and Testing Capabilities Office has been remodeling the public areas of various test facilities and asked us to create
supersonic wind research facility.
Oh, hey, it's me. I'm talking to myself. The AETC has been remodeling the public areas of the wind tunnels, and they asked us to create a VR visualization of the lobby of two of the wind tunnels here at Glenn. So in this visualization, what you're seeing, this is recorded from the Quest, which is why it has that weird square aspect ratio. The user starts outside the facility. They can look around. As you saw earlier in the video, you can look down at your hands and see what the controls are. If you enter various locations, it triggers that this virtual tour guide that pops up and gives you information about what you're standing by, what you're looking at. You can see you can reach out and grab various items like this pamphlet here. You can interact by direct navigation or teleporting. Sometimes some of the choppiness in this video is just because of the frame rate, but it also supports ratcheted rotation so you don't get motion sick when you're turning around. The interaction in this visualization is provided by a custom-built interaction system that leverages Unity's XR interaction toolkit with various additional capabilities to tie it into things such as the custom narration system that I've built here. Some of the triggers, a lot of these are location-based triggers, but they're on the one wall. You can actually approach the wall, and not where you're looking, but where your head is facing, you can trigger various information to pop up. The Quest does not support eye tracking yet. In the future, that would be ideal, is to be able to tell where the user is looking and then trigger information based on that instead of just the head direction. And in this video, just like the previous one, you can approach screens and we can show video content inside of VR. In the future, we'd like to expand the areas that the user can explore to include the actual wind tunnel areas and be able to talk about the testing done there. As you saw in one of the previous visualizations, we've shown like walking through a wind tunnel and showing the data overlaid on the wind tunnel. Additionally, this application was created for VR, but during the pandemic, we created a non-VR WebGL version that runs in a web browser so that we could reach a broader audience when we no longer were having public tours of the lab. Next slide, please. I also wanted to share, this project is not currently VR, but it's scientific visualization and VR adjacent. So researchers at Glenn have been developing techniques to study Hall effect thrusters, so ion engines, in our vacuum facilities using what's called laser-induced fluorescence. And Herbert, if you could play that video if it wants to play. So this clip is just a small section of a larger video in an effort to explain the tests themselves. And although the deliverable for this project is not currently VR, the pipeline for us was basically the same. This was taking all of the CAD geometry, massaging it, bringing it into Unity, and using Unity to generate a rendered movie, heavily utilizing Unity's timeline feature. And since we have all these assets in Unity now, we can now leverage that to create our VR version sometime in the future if we like. And I do want to point out that I took advantage of KSC's Armit tool to get some of these models into this. So thank you to KSC for that. And that's it. I will pass it on to our interns, I believe, have the next slides.
So wrapping up kind of our overview and Paul's demo, we did want to talk about some of the things on the horizon. More web-based, Paul already touched on that, but Caleb will talk about some more about that. We have a project to do some AR for visualization of data for digital twins, and just trying to blow through a lot of these things. We're working with local universities, stay on the bleeding edge, and just in general, adapting to the post-COVID world with a variety of different things that you see listed there, like more gestural interfaces, less touching, and non-headset based visualization technologies. And now we will turn it over to our first intern, Jacob Peterson. He goes by Jake, so take it away, Jake.
Hello, everybody. So I'm going to be talking about my project and what we're doing to implement X-Plane and VR for the Susan concept aircraft. Like Herb said, my name's Jake. I'm a GRC GVIS intern. All right, next slide, please. So some of you might know, some of you might not. Susan is a concept aircraft. Susan is an acronym for subsonic single aft engine, which kind of explains the concept here. You have a single rear-mounted turbofan and then electric motors in the wings. Next slide, please. So a little background on some software. X-Plane, which the project is in, it's a high-fidelity, realistic flight simulator. It's common among professionals and enthusiasts around the world. X-Plane, it ships with an app or software called PlaneMaker, which allows users to implement and create their own aircraft in the simulator. It's amazing, but there's a lot of shortcomings with it, which we'll get into. And there at the bottom right, you can see a skeletonized model of Susan in PlaneMaker. Next slide, please. So those shortcomings with PlaneMaker are mostly visual. So whenever there is a highly detailed model in X-Plane, most of the time it starts at a more comprehensive 3D modeling software. So for that, we're using Blender. And here on the right, you can see a mesh in Blender, I think 2.79 of Susan, which I made. And it just gives you a lot more freedom for high quality 3D modeling. Next slide, please. So finishing touching on the project, the expected outcome is to have a high fidelity model to first generate excitement among the amazing people at NASA about hybrid concept aircraft, but eventually through a public release as well to bring that excitement to the public. And next slide, please. And so this is just a quick demonstration of a short final of the current state of the model. We can kind of skip through this, but you can kind of see what X-Plane looks like, and you'll see some, not only my mediocre piloting skills here, but also some weight and distribution stuff I'm working through in PlaneMaker. So it's really just juggling from Blender to PlaneMaker to X-Plane, and then figuring out what needs fixed, going back and just kind of rinsing and repeating. All right, next slide, please. So now the good stuff. So X-Plane actually at the outset, if your VR system is wired, X-Plane actually supports it. So in the settings menu, you'll have a tab for your VR settings, which is awesome. And then if you're wireless, you'll have to use an app such as Oculus's Virtual Desktop, which costs about $20, but that functions just as good. So besides the obvious benefits of bringing VR to flight sim, field of view and depth perception, On the right, you can see an image from a video KLM published, I think, on LinkedIn. And they're using VR to train their pilots. And you can see they've made like an app to label certain knobs there. And they have like a laptop also, if they were looking down more, that explains what the switch does. And they even have a program where pilots can get trained to fly with a virtual first officer. And they talked about having a lot of success with training in VR. And that kind of brings me to the next point, how cost effective it is compared to a big hardware sim. Those big gyrating hardware sims, they can cost upwards of $10–12 million, and they have a shelf life. So, you know, if you have like a 757, for example, and the airline quits using the 757, then they pass it on to like a museum or a school for hardly pennies on the dollar. So with VR, you know, you could just have, for example, a Quest 2 and some supporting hardware for inputs in a gyrating chair, which we actually have at the cave that we're going to be putting in the cave and implementing with VR in the setup you can see in Herb's camera. And so that's kind of something we're working on. But the benefits are definitely outweigh the cons here. And not to mention it's super maintenance friendly. You know, you're doing compared to like hardware maintenance, it's absolutely much more maintenance friendly, just software mostly. So next slide, please. So finishing up, some goals for my project with the team, get that 3D flight deck integrated in the Susan model, so that way we can successfully use VR and show some awesome demonstrations, finish the exterior 3D model, and continue to refine the flight characteristics of the model to mirror pretty close to a 737. So that does it for my presentation.
Okay, thank you, Jake. Awesome job.
Thank you.
And now we're going to turn over to Caleb.